Hello everyone, this is 10th lecture and in this lecture we shall discuss about the electric dipole and electric dipole moment. And a numerical I have selected. First of all, what is electric dipole? Yesterday we have discussed about it also. When we draw electric line of forces for an electric dipole. What is electric dipole? When two equal and opposite charges are placed very close to one another. Plus Q charge, minus Q charge. If they are placed very close to one another, then they behave like a single unit and produces common electric field and potential. This system of charges is called electric dipole. If O is the middle point of the dipole and this is the length A or distance A from the midpoint of each charge, and total separation of charges is 2A. So this is called electric dipole. Electric dipole, a system of two equal and opposite charges placed very close to one another and produces common electric field and potential is called electric dipole. Electric dipole. So when two equal and opposite charges are placed very close to one another, then they behave like a single unit and produces common electric field and potential. This is called electric dipole. Sometimes we discuss about the monopole also. Monopole is a dipole with infinite separation. Monopole is a dipole with infinite separation. A single charge can be considered as a monopole and it also considered as a dipole with infinite separation. And if two dipoles are placed very close to one another, then we use the term quadrupole. Again I am telling you, if two dipoles are placed very close to one another, then they are termed as quadrupole. For a monopole, the electric field intensity is inversely proportional to square. For a dipole, it is inversely proportional to cube of a distance. And for a quadrupole, it is inversely proportional to the fourth power of distance. For monopole, it is square of distance. For dipole, it is inversely proportional to cube, and for quadrupole, it is inversely proportional to fourth power. Now we shall discuss about the electric dipole moment. Electric dipole moment. Electric dipole moment, it shows the strength of a dipole and it is the product of either charge. We have considered equal and opposite charges, so we consider either charge and separation of charges. The distance of each charge from midpoint is A, then the separation of two charges is 2A. So the dipole moment is the product of either charge, means Q, and multiplied with the separation of charges, means 2A. This is called electric dipole moment. It is a physical quantity and it is a vector quantity, also has direction from minus q to plus q. Remember that The direction of electric field is positive to negative, but the direction of electric dipole moment is minus q to plus q. So electric dipole moment, the product of either charge and separation of charges is called electric dipole and electric dipole moment is electric dipole moment is equal to either charge multiply separation of charges. It is denoted by P, either charge means Q, and separation of charges is 2A. The SI unit, the unit of charge is coulomb, and separation is distance, and it is measured in meter. So coulomb into meter is the SI unit, and dimensional equation, the dimension of charge is A1 T1 and separation is L1. So M0 L1 T1 A1 is the dimensional equation. It is a vector quantity. What is electric dipole moment? Is a vector quantity. And direction of electric dipole moment will be from minus q to plus q. Remember it. The direction of electric field intensity is from positive to negative, but the direction of electric dipole moment means P is from minus q to plus q. So this is electric dipole and electric dipole moment. Now we shall discuss about a numerical. A system has two charges, QA is equal to 2.5 into 10 to the power minus 7 coulomb and QB is equal to minus 2.5 into 10 to the power minus 7 coulomb, are located at points. The points are given in the form of coordinates 0, 0, minus 15 and B, 0, 0, 15 centimeter. What is the total charge and electric dipole moment of the system? So here is the answer of the question. Question number second. The first charge QA is equal to 2.5 into 10 to the power minus 7 coulomb. QB is equal to minus 2.5 into 10 to the power minus 7 coulomb. The coordinates are 0, 0, minus 15 and B, 0, 0, 15. If we calculate the separation 2A, the separation of charges will be, this is coordinate x1, y1, z1, this is x2, y2, z2. So according to formula, x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. And if we put the values 0 minus 0 whole square plus 0 minus 0 whole square plus minus 15 whole square. So the value of 2A will be 0 plus 0 plus minus 30 whole square, and the answer will be 30 centimeter. Total charge will be 2.5 into 10 to the power minus 7 plus minus 2.5 into 10 to the power minus 7. So total charge of the dipole will be is equal to 0. And the dipole moment, again P is equal to Q into 2A. Either charge, the value of charge 2.5 into 10 raised to the power minus 7. And this is the separation, 30 centimeter. We shall convert it into meter, 30 into 10 raised to the power minus 2. And when we solve it, 10 and 10 cancel out, 75 into 10 raised to the power minus 9 coulomb into meter. This is the electric dipole moment of the system, and its direction will be from minus Q to plus Q, minus Q to plus Q charge. And this is the electric dipole moment, and this is the total charge of the system. Total charge of the system will be 0, and electric dipole moment is 75 into 10 raised to the power minus 9 coulomb into meter.